Hey folks, Wolf here, ready to deliver you another installment of Unit 2 of Chemistry. This time we're looking at applications of stoichiometry, and hopefully in this session we will get through limiting reactant, theoretical yield, and perhaps also percent yield, but we'll see where the time takes us. Okay, hopefully you're reading through the notes before you watch the screencasts. As we look at these notes, it defines for us limiting reactant, which is if you're given two reactants, which one limits how much we can make. Ms. Malcolm always likes to use the analogy, if you're given 10 slices of bread and 3 slices of cheese, which is your limiting reactant? Well, it's the cheese. You can make 3 grilled cheese sandwiches if that's what you're trying to do. Whereas with 10 slices of bread and unlimited cheese, you'd be able to make 5 sandwiches. So limiting reactant is a specific quantity associated with a specific reactant that limits how much we can make. The notes go on to show you a couple examples of how that works out. Please take the time to read through them. We're going to dive right into the first example that is left blank. And now I'm going to take a closer look. The equation on which the problem is based, I put a weird version of a green star next to. It says copper plus 2 moles of silver nitrate yields copper nitrate, probably copper 2 nitrate, and 2 moles of silver metal. The example that we are being asked to do simply involves going from moles to moles. There's no grams to moles conversion going in or out. It says if 12 moles of copper reacts with 25 moles of silver, what is the limiting reactant? I'm now going to explore which makes more product, 12 moles of copper or 25 moles silver nitrate. And I'm just going to choose one product to focus on, and it looks to me like silver would be easier. So here we go. First, let's look at 12 moles copper, 12 moles Cu. And since we're going from moles to moles, I don't need to do any conversion. So 12 moles of copper in the balanced equation, there's 1 mole of copper, and if I were to put 1 mole of copper in with unlimited silver nitrate, I'd get 2 moles of silver out on the other end. So it's a 2-to-1 ratio, so it should make sense that given 12 moles of copper and an unlimited silver nitrate, I could get out on the other end 24 moles of silver metal. Now look at 25 mole of AgNO3, and we'll do the same thing, same process. For every 2 mole, I take these coefficients, 2 and 1, from those provided in the equation. For every 2 mole silver nitrate, on the other end, I get 2 moles of silver. It's a 1-to-1 ratio, and that means I end up with 25 moles of silver. So, because of the fact that 12 moles of copper will produce for me 24 moles of silver, and 25 moles of silver nitrate makes 25 moles of silver, I now know that my limiting reactant is the 12 moles of copper. So in this example, we just went from moles given to moles wanted. Let's turn the page. Okay, in the example shown here, if 67 grams of copper reacts with 170 grams of silver nitrate, what is the limiting reactant? Let's get the equation down. 1 mole copper, 2 moles of silver nitrate. Just so we can refer to this as we work. I believe that's the equation. Nope, something's not right. 2 moles of He. Okay, so back to the scenario at hand. 67 grams of copper reacts with 170 grams of silver nitrate. What is the limiting reactant? So in this example, folks, the author gives us grams to work with. And so we're going to need to go from grams to moles to moles here. So we're going to need to convert from grams to moles, and then from moles in to moles out. Okay. So 67 grams Cu. I'm going to see how many moles of silver this is going to make for me. Copper has a mass of 63.55 grams for every 1 mole. So this gets me how many moles of copper they're giving me. And then, now I'm going to use the ratio provided for me. For every 1 mole of copper, I get 2 moles of silver. So the only step we added from the last example to this is that first one where we convert from grams to moles. Let's look at what happens with silver nitrate. And then we'll do the calculations at the end. 170 grams silver nitrate. I should have massed things out ahead of time, but bear with me while I get the mass of silver nitrate. So silver has a mass of 107.87 grams per mole. Nitrogen, 14.01. And then 3 atoms of oxygen at 16 apiece is 48. So the molar mass is 169.88 grams per mole. And furthermore, for every 2 moles of silver nitrate, we get 2 moles of silver out the other side. Bear with me while I calculate. .1 mole silver. And 1.0 moles of silver. So folks, when you look at 67 grams of copper versus 170 grams of silver nitrate, and you are asked what the limiting reactant is, your work should look like this. And since silver nitrate only produces 1 mole of silver compared to copper's 2.1, we know that our limiting reactant is 170 grams of silver nitrate. I'm going to move on, and if I need to, I will split this. So theoretical yield, the notes tell you, is the maximum amount of product that is possible to make from the reaction. So this will be based on the limiting reactant. I'm sure I'm foreshadowing in here. The theoretical yield is reported in grams, and the process outlined is determining what the limiting reactant is, and then convert the molar quantity of the product that you figured out from the limiting reactant into grams. A couple examples are done out for you. Let's scroll down and look at the first example that's not done for you. Using the balanced equation above, what is the maximum mass of calcium chloride that could be produced from the reaction of 45 grams of hydrochloric acid, that's HCl, and 112 grams of calcium carbonate? The first thing I'm going to do is figure out what the limiting reactant is, and then what I'm going to do is figure out what the theoretical yield is. And I'm being careful here because the question asks about the maximum mass of calcium chloride. So maximum mass is the same thing as theoretical yield. It's that which is theoretically possible. And here we go. So I'm going to figure out which is the limiting reactant first. I'm going to aim for the product calcium chloride, And then depending on how many moles my limiting reactant can make, I will then convert that molar quantity to a grams quantity. So here goes. 45 grams of HCl, that's hydrochloric acid. There are 36.46 grams in 1 mole of HCl. And in the balanced equation, it is told to us that for every 2 moles hydrochloric acid, we get out 1 mole of calcium chloride. I'm going to do out the math now. And I get 0.617 moles of CaCl2 that could be produced from the 45 grams of hydrogen chloride or hydrochloric acid. Then we have 112.5 grams of CaCO3. Calcium's mass is 40.08 plus carbon's 12.01 plus 3 atoms of oxygen, that's 48. There are 100.09 grams in 1 mole of calcium carbonate. And if I do the stoichiometry for every 1 mole of calcium carbonate, I get out the other side 1 mole calcium chloride. Pardon me while I do some math on my calculator. And I get 1.124. So it is at this point that I have identified what my limiting reactant is. It's my 45 grams of hydrochloric acid, because that only produces 0.617 moles of calcium chloride in the presence of plenty of calcium carbonate. So now what I'm going to do is I'm simply going to convert that molar quantity to a gram quantity, which will be equivalent to the maximum mass of calcium chloride product that could be made. So here we go. I'm just going to use what I've already created. Pardon me while I do a little bit of math here. The mass of calcium is 40.08 grams plus 2 times 35.45, that's 2 atoms of chlorine, is 70.9. And the mass of that is 110.98 grams per 1 mole of calcium chloride. Now I'm going to do out the math. And my theoretical yield is 68.5 grams of calcium chloride. So that is theoretical yield. I'm going to stop here, and then next time I'm going to pick up where we left off and use theoretical yield as a basis for talking about